And this is Libby, and I'm going to be talking about Koch and Pasteur's vaccination. Using Pasteur's germ theory, a German doctor called Robert Koch explained that Germans could use human disease. He linked a disease to the microbe that caused it. This was the beginning of bacteriology. Koch showed that germs were not all the same. He identified the different microbes that caused anthrax in 1876, septicemia in 1878, tuberculosis in 1882, and cholera in 1883, by injecting animals with diseases. He then dyed bacteria and viewed them using microscopes. Other scientists then discovered typhus in 1880, pneumonia in 1880, tetanus in 1884, diphtheria in 1884, and the plague in 1890. Koch and Pasteur's studies were picked up by many scientists in Britain. John Tyndall gave lectures on germ theory to British doctors. He refuted or disagreed with Bastian's ideas of spontaneous generation. Dr. William Roberts created a medical version of germ theory. William Cheney translated Koch's work and highlighted that not all microbes caused harmful disease. Koch and Pasteur inspired a generation of scientists who were called microbe hunters. These scientists became interested in diseases and how to prevent them. So to recap when those microbes were identified, we know that diphtheria was identified in 1884, typhus in 1880, tetanus in 1884, the plague in 1890, and as we learned up here, pneumonia in 1880. So how did Koch view the bacteria in a microscope? We know that he dyed them before placing them in the microscope to see the effects. So Pasteur and Koch tried to apply germ theory to develop more advanced vaccinations. In 1879, Pasteur accidentally showed that vaccinations could prevent disease. After a researcher, Charles Chamberlain, left out a cholera culture over the weekend, we discovered that weakened or attenuated cholera germs could make a chicken immune from later, stronger bouts of cholera. In 1881, Pasteur produced a weakened or attenuated vaccine for anthrax in sheep. By 1884, Pasteur created a vaccine for rabies. A year later, this was applied to human subjects. Pasteur's contribution to vaccines is so significant because it allowed some of the world's deadliest diseases to be eradicated. In 1871, the Franco-Prussian War between France and Germany ended. Some historians think national rivalry between Pasteur and Koch drove developments. Scientific advances were propelled forward by competition. There was internal rivalry to understand a germ called diphtheria. By 1890, Pierre Roux had shown that diphtheria produced a poison. Later in 1890, Emile Behring showed that if diphtheria was diluted, it could produce an antitoxin. So to recap on this rivalry, by 1890, Pierre Roux had shown that diphtheria produced a poison. And later in this year, Emile Behring showed that if diphtheria was diluted, it could produce an antitoxin. So to recap about the rivalry between Koch and Pasteur, we know that the Franco-Prussian War ended in 1871. So Koch and Pasteur inspired a generation of scientists who were called microbe hunters. These scientists became interested in diseases and how to prevent them. In 1881, Pasteur produced a weakened, or we can also call this an attenuated vaccine for anthrax in sheep. By 1884, Pasteur created a vaccine for rabies, and a year later this was applied to human subjects. So just to recap on what we've learned about germ theory in the UK, we know that Dr. John Tyndall created Dr. William Roberts created a medical version of germ theory. We know that John Tyndall gave lectures on germ theory to British doctors, and that William Cheney translated Koch's work and highlighted that not all microbes caused harmful disease. Okay, so that brings this session to a close on Koch and Pasteur's vaccination. Thank you for listening.